All right, ladies and gentlemen, the next lesson that we're going to be going through are exponents and dealing with different kinds of exponents. Most notably for this week, it's going to be dealing with zero exponents and exponents that are negative. Exponents are a great short way to represent very large numbers and very, very small numbers. So when we start to think about exponents, what I really also want you to think about are fractions. Okay, because you might not think about it as an exponent. Exponent might just be another number. However, when we look at the different kinds of values that we can get for exponents, oftentimes they deal with fractions. Okay, so without further ado, let's get involved in this. Now, right here, this number right here is a million. How great would it be to have one set of $1 million, right? So basically, this exponent tells us that we have one of these $1 million. If this was a 2, that would mean that we would take that base of 1 million and multiply it times itself 2 times. Okay, a lot of us get confused thinking that we multiply this base times this exponent here, but that's not the case. Okay, again, it's that number times itself that many times. So the base times itself, the exponent number of times. Now let's say that we had something like 1 million over 1. Well, let's see what this looks like. So I'm going to throw in 1 million here. That's 6 sixes, or 6 zeros, pardon me. I'm going to raise that. So my exponent key here is this upside down V. It's also called a caret button. I'm going to call it the exponent button, okay, or the exponent key. So I'm going to press that. I'm going to throw in a -1, being careful that we're using the negative here. We don't want to use minus. And look what we end up getting. We end up getting this very, very small number, okay? This is written in scientific notation. Exponents are a big piece of scientific notation. Again, it's a short way to represent very large or very small numbers. So basically what happens here is this number ultimately becomes 1 over 1 million, okay? And that negative exponent has everything to do with it. The positive exponents are happy, make the bases happy, but the negative exponents force us to have to do something. Okay, so let's just check out some positive exponents and see what they look like. 3 to the 5th gives us 243. Again, if we use our calculator, 3 caret, or exponent key, 5, and an enter, it gives us 243. So our calculator will render the simplified form for us, and that's good news. So anytime that you see a number, you can throw that into your calculator, guys, and you should be in good shape. All right, so 7 squared is 49. 2 to the 7th is 128. In other words, this is 2 times 2 times 2 times 2 times 2 times 2 times 2. All right, so you're multiplying 2 times itself 7 times in order for us to get that 128. It's not 2 times 7. That's obviously 14. So making sure that you're not forgetting the skill that's required here, and that's exponent is basically taking that base times itself the exponent number of times. So here we could rewrite this 35 times 35 times 35. In shortened form is really 35 raised to the 3rd power. And I'm cool with you leaving this as an answer. Okay, if you did your actual calculation and you did 35 caret 3, it gives us 42,875. That would be totally fine as well. Here 19, if you count up the number 19s that we're multiplying times itself, you would see that that would be a 9. Okay, so 19 raised to the 9th power is a very large number, and we're just going to leave it as 19 to the 9th. All right, so our base here, when we're dealing with a power, if you will, the base is our 4. The exponent is a small superscript. It's raised to the top right of a number. That's how you know that what it affects. The exponent in this case is 3. Together, the base and the exponent together are called power. Called powers. Okay. So again, keep that frame of mind. Exponents work as fractions. We saw it briefly here, but let's really see what's happening here. For every non-zero number, if we raise something to the 0 power, all right, let's do this for example. Let's raise our 6 here to the 0 power. We're going to get 1. All right, and so basically, ultimately, what that means is that we have this base divided by itself. I know it sounds kind of strange. It will make sense next week when we really look at dividing common bases. But the bottom line here is anything to the 0 power gives us 1. So if we have this base in parentheses. What that 0 means that it's affecting everything inside the parentheses there. So everything there becomes 1. All right. Now, we're going to look at some instances where the negative might not be touching that 0 exponent, and that could be problematic. It's going to affect our answer. So again, anything that 0 touches to the left of it means that that base is affected by the exponent, and that we need to do whatever needs to be done with that base. So our other rule here is we have negative exponents. So a negative exponent affects everything that it touches to the left. All right, so this negative exponent here only affects what's inside the A here. And then what it does is that we have to move the exponent. If it's at the top, we have to move that whole system downstairs. Okay, and I like to call them upstairs and downstairs for the fraction. So if we're starting, remember, we can make any fraction or any number a fraction or any expression a fraction by putting it over 1. So this negative exponent would make this whole system come downstairs here, and then we end up, once we move it, it becomes a positive exponent. So let's see what this looks like. 4 to the negative 2. Let me put this in here. 4 caret negative 2. And then we get this really kind of small decimal. Well, let's see what that looks like in fraction form. So I'm going to press math, and I want the fraction form of that, so I'm going to press enter, and then enter again, as this just shows you what the calculator is doing. And so we end up with 1 over 16. But isn't 4 squared 16? Yes, it is. 4 times 4 is 16. Okay, so on the bottom here, again, they made this a fraction. Okay, and so what they took is that negative exponent and the base, and they brought it downstairs. Once they move it downstairs, there's no longer a negative exponent. All right, and 4 squared, of course, is 16. And that is exactly what we got from our calculator here. So if you just have numbers and you type it in exactly, it's all good using your calculators to help you find your answers. That's excellent. It will also help you understand the theory behind it more. So when we're talking about variables and with those exponents and what we have to do with those, that's a big deal. And so we want to make sure that we understand the theory so that everything else is just second nature. All right, so down here, that this whole base of negative 3 is raised to the negative 5th power. So we move that base of negative 3 downstairs. Notice the negative is not affected by the exponent here. The only thing that changes is the exponent. The base does not change. All right, so we have 1 over the quantity negative 3 raised to the 5th power. And if I were to put this into my calculator, negative 3 raised to the 5th power, in the bottom we're going to end up getting negative 243. So notice how I kept the parentheses in there as I calculated that in the calculator. I used the parentheses. If I didn't use the parentheses, it could ultimately affect our answer. Okay, so let's say that we ended up putting 0 to the 0 in our calculators. This is going to be problematic for our calculator because ultimately what we end up getting is a domain error. In other words, a division by 0 error. So basically what that means is it's not good. All right, so we can't have anything to the 0 power. Now look what happens here. According to our new rule, if we wanted to get rid of this negative exponent here, we know that we'd have to put the 0 in the denominator, okay, because we would have to move it in order to get rid of our negative exponent. We got to get rid of all our negative and 0 exponents, okay? So we move that guy downstairs, it then becomes positive. But even if I put this into our calculator, I make my math, go over to frac, and watch what happens here. I'm going to put a 1, I'm going to put a 0 raised to the 2nd power here, enter, and again, you're going to get a division by 0 error message. We can't do it. We can't divide by 0, okay? So that's why we can't really do this. We can't divide by 0, so this expression is considered undefined. Or there would be no solution for that particular situation. So we can't have zeros in the denominator. It'll give us an error. Okay, so let's go through some examples here. I kind of have the answer key out there, but I just want to kind of show you what's happening. We have our Zero power, okay, our zero power rule is anything to the zero power becomes 1. So that 0 affects everything that it touches just to the left of it. So this x, this whole thing becomes 1. Over here for b, now if I move this line here, basically what I was doing is striking through anything that the exponent touches. That results in 0. So the 0 affects only this x. So that part becomes 1. But we still have this 2 raised to the first. Remember, this is really 2 times x to the 0 power. So that 2 stays. But the x to the 0 becomes 1. 2 times 1 is 2. Okay? So all that becomes 2. 4 to the 0. Anything to the 0 power becomes 1. Here we have, now let me erase this so you can see kind of like what we really have here. Here we have negative x to the 0 power. Again, this is really like negative 1 times x to the 0, okay? Again, anything to the 0 becomes 1. So that x becomes 1, but we still have this negative 1 here that is multiplied to that 1, and that's why we end up getting negative 1. So for something like this, though you can't type that into your calculator, you really got to understand that when we have a negative out front, that 0 is not technically touching that negative 1 or affecting it. So it only affects this x here, and this is where the exponent theory gets a little confusing. All right, so we have negative 2 times x to the 0. This x to the 0 becomes 1. We end up with negative 2 times 1, which gives us negative 2. Okay, so only the part that's affected by the 0 exponent is the x, and that's the only part that kind of cancels out. All right, for letter F, we have 1 over y to the 0. Well, anything that's touching the 0 exponent becomes 1, so we end up with this 1 over this new 1, which really is 1 over 1, gives us 1. Okay, so the total answer for letter F would be 1, or I would be okay with 1 over 1. And then finally, this 0 exponent really affects everything inside the parentheses here. It affects the 2 and the x. Everything in there becomes 1. All right, let's see some more examples here. We have negative 4 times x to the 0. The x to the 0 becomes 1, but this is really negative 4 times that. So we have negative 4 times 1 gives us negative 4. The 0 exponent affects everything inside the parentheses, so all that stuff becomes 1. Same thing here. The 0 affects everything inside the parentheses, so all that becomes 1. Here for letter H, notice the difference between G and H. Here, the 0 affects the 3, but technically what we have out front is this negative 1. Remember, if any negative value that we have is really that value times negative 1. So negative 5 is really 5 times negative 1. Negative 3 is really 3 times negative 1. So I'm going to throw this negative 1 out front here. That 0 only affects that 3, but we still have this negative 1. If you wanted to check it out for yourself, negative 3 raised to the 0 power, it gives us negative 1. Okay, again, because we really have here is 3 times negative 1, and that negative 1 out front is not affected by the 0 exponent. Last one here, the x to the 0 becomes 1, so we end up with 1 over 3 to the 1 times 1, which is just 1 over 3. So only the x to the 0 gets knocked out, everything else is cool. Last portion of this is looking at some examples here where we have negative exponents. And remember, our negative exponent rule is wherever there's a negative exponent, we have to move it from one side of the fraction to the other. So if we have a fraction starting off with a negative exponent in the top, that means that we have to move it down to the bottom. And once we move it down to the bottom, and it becomes positive. So h to the negative 4th, we can't have negative exponents in our answer. We bring it downstairs. Once we bring it downstairs, it becomes h to the 4th, and we just put a 1 of a placeholder on top in the numerator. Okay, here we bring x to the negative 2, we bring that up top. 3, remember, it doesn't have a negative exponent, so he's fine, he stays put, and then we end up with 3 times x to the 2nd. Y to the negative 3 comes downstairs. That's the only one that's affected by the negative exponent. Everything else stays put. For letter D, the x to the negative 4 moves downstairs. The y to the negative 3 moves upstairs. And once we move them, remember, we no longer have negative exponents. And then finally here, we move the x to the negative 9 up top. That's the only thing that moves. Everything else stays put. Here's a couple more examples for you as our video winds down. If you have any questions, make sure you email me.